professor, physician, epidemiologist. I am Dr. Sri Banerjee. Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And in this video I'm going to be going over some relationships between dependent and independent variables which are not traditionally considered customary. I'm going to go over some relationships which are a bit, you have to think a bit outside of the box. And I'm going to show you what I mean in a moment. So what I'll do is I'll transition over. First of all, let me make a quick demonstration here. So if you have, usually when you have a typical research question, you have one predictor variable, which I'm going to label P, and then you have one outcome variable. So this is the usual relationship that is explored and actually typified within the context and framework of a research question, maybe at a doctoral level, also at a master's thesis level. But if we were to look for, first of all, thinking about a moderator variable, right? So if I draw a moderator variable here, then that could actually mix some of this relationship up and allow you to explore something a little differently. So the first thing that I talked about, first of all, is the moderator variable. So I'm going to label this mod. But instead of the moderator variable, if we were to look at a mediator variable, so what does that mean and how is that different? So if we were to take a step back here and then take a look at the same diagram, then I'm going to draw the mediator a little differently because to distinguish it from the moderator variable. So what the mediator variable is actually doing is there's a relationship between the predictor variable and the mediator variable, and then there's a relationship between the mediator variable and the outcome variable. So here the mediator variable is actually serving both as the outcome variable and then the predictor variable. And so when you look at the outcomes and when you look at the output, which is part of the process module, which is produced by a person called Hayes, Andrew Hayes, and he actually goes over this in a lot more detail. So I'm going to go over that in the next segment of this video. But this is the person that has created a lot more and created this special module. So now that I diagrammatically described a little bit about mediation versus moderation, let me tell you a little bit about what kind of the theoretical background is. And Andrew Hayes, Dr. Hayes actually produced this module and this paper. He published this white paper, and he's from Ohio State University, providing about analytically questions of how are typically approached using process or mediation analysis. So this sort of mediation is something that he found, to be very useful to typify. And then in terms of if it's a question of when, and this is really important, if it's a question of when, then a lot of times this is answered through means of moderation. Now, of course, this has ramifications in public health versus if you're looking at variables in education. This might be a bit different. So he goes over an example of video games, violent video games, and the interaction of that and aggression, if there's some sort of mediation variable which interacts, or something that is some sort of putative causal effect, and it may not be even an actual causal effect, but something that is presupposed to be a causal effect is interacting. So sometimes there can be a combination. For instance, there can be a moderated mediation, mediated moderation. So that's something that he goes over in this part of the paper. And then also kind of looking at it as conditional process modeling. So he goes through a lot of good detail and a lot of also equations which better correspond to how some of these are provided in notation. So scientific notation is provided here. And they're good to go over. However, for the purposes of this video, I'm going to actually scroll down all the way to the bottom and focus on models 1 and models 4. So model 1 is very important because model 1 is actually going at the very basic level and saying that the mediation, or actually in this case, the moderation is taking place in the relationship between x and y. And I'm going to go over an example in the next part of this video. But you have, first of all, a direct relationship between the predictor variable x and outcome variable y. And then m is coming in and acting as the moderator in this relationship. So suppose different levels of m is producing various outcomes y. And that is kind of shown here within this statistical model. That this interaction term between x and m is producing a significantly different effect, C3. So x, as you can see, has a certain effect. M has its own effect. And then the interaction has its own effect. So that's the main premise behind process model 1. And then if you look at process model 4, that is looking at a very basic level, that is looking at mediation between the relationship of x and y. So if that relationship is mediated, then this is what is going on. And I explained this at the beginning of the video, but I think sometimes a lot of times it's confusing. And so there's a relationship between, so what makes this unique is that the mediator variable is not only acting as the outcome variable for x, but also the predictor variable for y. So the first thing you see is there is a direct relationship between x and y, but then there's also a relationship where m is not only the outcome variable, but also the predictor for y. There's different iterations of this, so there could be multiple mediators that you could be testing. And I'm going to show you an example of this. And then there's a potential for sequential mediation that is possible. So that's what means by the bottom when we're talking about M1 and M2. So this is what process models 4 is important for. Remember 1 and 4 from Hayes. And then I'll explain an example that I conducted in SPSS. So now in this segment of the video, I'll show you how to run a process module created by Dr. Hayes in SPSS. So the steps that I conducted before this, I'm going to show you briefly, and then to prepare this view that you're seeing right now. So first of all, this is National Health and Nutrition Examination Survey. The analysis that I'm going to run and conduct has never been run before. This is an original analysis that I'm conducting for this demonstration. And theoretically, this could be findings for a paper. Additionally, I'm going to show you the preparation for this. And so what I actually did was I went to Andrew Hayes's website, and there's pretty clear instructions on how to download that. But here is the here is the place where you actually download and install. Actually, more so install the bundle. So there's an actual bundle that you go in, and it says install custom dialog, and what you'll be downloading is process.spd. So you find where this process.spd file is. You download it from Dr. Hayes' website, and then you just open, and it automatically installs. Once you do that, then you go into Analyze, and then you can go into Regression, and lo and behold, you have Process version 4 by Andrew F. Hayes. And so this is installed in one of the newest versions of SPSS currently found. And if we open up this, we'll see, and I had already entered some interesting variables. So this y variable, this outcome variable, is a Framingham risk score that I had created from various multiple patient information in NHANES. This is very unique, this risk score that I have formulated and created. It's a composite score. And additionally, so this was naturally a continuous variable. So as an outcome variable, I was also looking for a predictor variable. So one such predictor variable for cardiovascular risk is cholesterol. So total cholesterol was the main X variable. And then for mediation, remember I said in model 4, so I wanted to first make sure that, yes, we do have the correct model. So model 1, remember, model 1 was moderation, right? So that's not what we're after. We're looking for mediation. And mediation of two variables. So two of those that work here are body mass index and C-reactive protein. So good covariate to look at, and you could potentially look at multiple, but age is a good covariate. And then you go into some of these menu and look at some of the options. And you want to look at the total effect, the matrices, the interactions, everything. And then hit continue. And it takes a little bit of time to run. So now quickly running through the output, which took a little bit of a minute. The sample size is 9,777. And it's always good to take a look at what all of the different output means. And so I'm just taking a quick look. There is the output variable, CVD score, like we thought, and then the predictor variable, the total cholesterol, and the two mediator variables, C-reactive protein and BMI, and then the covariate. And so there is significance in quite a few places. So in general, there was significance with direct effects of total cholesterol over here, but also scrolling down, you continue to see some of these effects. So the best way to keep track of all of this is to create a diagram, which then you can use to demonstrate the relationship. So let's take a look here. What I suggest that you do is create a diagram such as this that I've created in the step above, and then see where there are relationships, where there are significant relationships, and then go from there. So for the purposes of this demonstration, I'm going to have to exit drawing here. So I think this visual goes away when I do so, but you kind of get the understanding. And then so what then you do is you're actually going, and so what is being reported here is really parts of the relationship at a time. So this is looking at the relationship between really total cholesterol and C-reactive protein, and then as if you want to, you can go and scroll back to the visual that I created, but this is looking at the relationship between total cholesterol and then BMI. So all different parts of the model, but it's good to be able to simultaneously consider all of them and see within the context which of them have a relationship. So as it turned out, within the confines of this analysis, we actually that I conducted here saw, I was able to demonstrate that within the relationship between total cholesterol and a CVD score as determined by the Framingham risk score, the 10-year risk score. So in that relationship, actually BMI was a significant a significant mediator variable, and then C-reactive protein was a significant mediator variable. So this is one of several findings that you can discern from this process. Now, most of the findings that I've shown you thus far are just one type of relationship, so kind of bivariate relationship findings. But this is kind of showing an overall ballpark sort of sense of what is going on within the model. So if we were to just quickly think about, and I'm going to use single letters to designate the predictor and outcome variables. If we were to just quickly draw out cholesterol is C, and then the well, I'm going to put CH for cholesterol, and then for outcome variable I'm just going to put CVD as CVD scoring. So what I'm going to demonstrate to you is kind of the piecemeal information that is coming in, and then what that means globally in terms of the whole model. So the first variable that we're looking at as a potential mediator is C-reactive protein. I've used this variable in multiple contexts because of the fact that it's an inflammatory biomarker, which is important to be taking a look at. So just looking at cholesterol and C-reactive protein, is there a relationship? And the answer is yes. It is working as a slight sort of mediator. And I can tell this because, of course, there's a direct effect, X versus Y, and it's a significant effect. And the effect is 0.03, so that's the direct effect. Now, if we look at the added effect, the total effect between cholesterol and C-reactive protein, and then C-reactive protein, and then CVD score. So if we add these two up, that added value is actually not much more. So the total effect, in fact, is not only, it's actually less. So in some ways, curiously, C-reactive protein is having kind of a negative sort of effect in the total effect. So this is something that would be interesting to kind of further explore. But if you were to not necessarily add the effects, but have kind of a measure of the indirect effect, then C-reactive protein would have a slight sort of negative effect. So this gives you a sense of how the model is operating, and these are bootstrapped confidence intervals. All of these confidence intervals for the effect are provided for you to report. So there's a lot of information that is reported here. Thank you for listening to this lecture.